Hello everyone. Today we're going to cover Chapter 3, Part C. Last time we looked at the following example. We had 7 activities, and this is the activity on Node network. And today we're going to answer the following questions. Compute the earliest start time, earliest finish time, latest start time, latest finish time, and slack time for each activity. The earliest start time, ES, is the earliest time at which an activity can start, assuming all predecessors have been completed. The earliest finish time is the earliest time at which an activity can be finished. The latest start time, LS, is the latest time at which an activity can start so as to not delay the completion time of the entire project. And the latest finish time is the latest time by which an activity can be finished so as to not delay the completion of the entire project. So the key word in this description is not delay the completion of the entire project. Now, to compute these, we're going to use the activity on node network. For each activity, we're going to draw a circle like this. And on top, we're going to put the name of the activity. And in the lower part, we're going to put the duration of this activity. And on the upper left part, we're going to put the earliest start time. In the upper right part, we're going to put the earliest finish time. And the lower left part, we're going to put the latest start time. And the lower right part, we're going to put the latest finish time. And we're going to fill out these circles for all the activities. So how can we fill out these circles? First of all, we're going to start from here, and then we're going to move forward and fill out the upper parts. In other words, we're going to compute the earliest start time and the earliest finish time of all these activities. So let's start from activity A. When is the earliest start time of A? Since this is the first activity, we can start this at time 0. When is the earliest finish time of A? If we start working on A at time 0, then it takes, the duration is 3 months, so we can finish it by 3. Let's go to B. When is the earliest start time of B? We can start B as soon as A is over, and A is done at 3, so we can start working on B at time 3. Now, when is the earliest finish time of B? If you start working on B at time 3, the duration of B is 2, so you can finish it by 5. Now, let's go to C. When is the earliest start time of C? We can start working on C as soon as A is over, and A is over at 3, so you can start C at 3. When is the earliest finish time of C? If you start working on C at time 3, the duration is 1, so we can finish this by 4. Now let's go to D. Here is the challenge. When is the earliest start time of D? Let's look at the predecessors. We need to wait until B is done and C is done, right? B is done at 5 and C is done at 4. Then when can we start working on D? Can we start working on D at 4? No, because we have to wait until both B and C are completed, and B will be completed at 5. So, and by 5, C will be completed. So we can start working on D at 5. So if you have more than one predecessors, you need to look at the earliest finish times of all the predecessors and pick the latest time, pick the maximum value. So the earliest start time of D is 5. Now, what is the earliest finish time of D? If you start working on D at 5, the duration is 3, so we can finish it by 8. Let's go to E. When is the earliest start time of E? 5. When is the earliest finish time of E? 5 plus 1, which is 6. When is, let's go to F. When is the earliest start time of F? 6. When is the earliest finish time of F? 6 plus 1, 7. Now let's go to G. Here's another challenge. We have two predecessors, D and F. And D is done at 8. F is done at 7. So when can we start working on G? If you have more than one predecessor, then we should take the latest value, the latest finish time, which is 8 in this case. And the earliest finish time of G is 8 plus 1, which is 9. Now we're done with the forward pass. Let's summarize what we discussed so far. The earliest start time of the first activity is 0. The earliest finish time is the earliest start time plus the duration of the activity. And if you have more than one predecessor, you compute the earliest start time by looking at all the earliest finish times of all the predecessors and take the maximum value of all of these. Now let's fill out the lower parts. This part is called the backward pass, and we're going to start from the last activity, and we're going to go backwards and fill out the lower parts. Now, before we start the backward pass, we need to find the duration of the entire project. At this point, we can find the duration of the entire project. What's the duration of the entire project? Let's look at the last activity. Here we have only one activity, last activity, which is G, and G is done at 9. So what's the duration of the entire project? 9. So using this, we can start the backward pass. So let's start with the last activity, which is G, and what is the latest finish time of G? The latest finish time is the latest time by which an activity should be completed without delaying the whole project. The key word is that we don't want to delay the whole project. So if you don't want to delay the whole project and the duration of the project is 9 months, by when should you finish this activity? By 9, right? 9. 9 is the latest finish time of activity G. Now let's go backward. What's the latest start time of G? Now we know we need to finish this by 9, and the duration is 1 month. So that means we need to start working on this 1 month before 9, so which is 8. Okay. Now let's go backward. Let's go to F. When is the latest finish time of F? Let's look at the follower, which is G. G is waiting for F to be completed, and G needs to be started by 8. That means F needs to be done by 8. Right? That's the latest finish time of F. When is the latest start time of F? F needs to be completed by 8. The duration is 1, so that means you need to start working on this 1 month before 8, which is 7. Now let's go to D. Let's look at the follower. G needs to be started by 8. That means D needs to be completed by 8. And the latest start time is 8 minus 3, which is 5. Now let's go to E. Let's look at the follower. F needs to be started by 7. That means E needs to be done by 7. And the latest start time is 7 minus 1, which is 6. Now let's go to B. Now here is a challenge. Now B has two followers, D and E. And D needs to be started by 5, and E needs to be started by 6. And we don't want to delay any of these. Then by when should we finish B? Can we finish B by 6? By 6? If you finish B by 6, then D is delayed. D needs to be started by 5 if you don't want to delay the whole project. So that means we need to finish B by 5. So if you have more than one follower like this, then you need to look at the start times, and you need to take the earliest time. Okay. That's the latest finish time of B. What's the latest start time of B? 5 minus 2, which is 3. Let's go to C. When is the latest finish time of C? Let's look at the follower. D needs to be started by 5. That means C needs to be completed by 5. What's the latest finish start time of C? 5 minus 1, which is 4. Let's look at B and A. Here is another challenge. A has 2 followers, B and C. B needs to be started by 3. C needs to be started by 4. So by when should we finish A? Whenever you have more than one follower, you need to take the earliest of the latest start times. So take 3. And 3 minus 3 equals 0. So now we are done with the backward pass. So let's summarize what we discussed so far. After finishing the forward pass, we can compute the duration of the entire project. The duration of the whole project is the maximum of the earliest finish times of the last activities. And when going backward, we start with the last activities, and the latest finish time of the last activity is the duration of the whole project. And the latest finish time is the minimum of the latest finish time, start times of all immediate followers. And the latest start time is the latest finish time minus the duration of activity. Now, what's the slack? Slack is the length of time an activity can be delayed without delaying the whole project. So let's compute the slack time. Let's start with A. Let's compare the earliest start time and the latest start time. The earliest start time is 0, and the latest start time is 0. That means we can't delay this project. If you delay this activity, the entire project will be delayed. So the slack time for A equals 0. We can compute the slack by looking at the latest finish time and the earliest finish time. How about C? The earliest start time is 3, the latest start time is 4. That means we can delay C by 1 month without delaying the whole project. So for C, it's 4 minus 3, which is 1. The slack is 1. Also, you can compute the slack time by comparing the earliest finish time and the latest finish time. 5 minus 4 is also 1. Okay, let's go to B. What's the slack for B? 5 minus 5, or 3 minus 3, which is 0. Let's go to D. What's the slack for D? 8 minus 8, which is 0. What's the slack for E? 7 minus 6, which is 1. Let's go to F. What's the slack for F? 8 minus 7, which is 1. G. What's the slack for G? 9 minus 9, which is 0. So to compute the slack time, we can take the latest start time and subtract the earliest start time. Or alternatively, we can take the latest finish time and subtract the earliest finish time. And if the slack of an activity is 0, that means the activity is the critical activity. The activity is on the critical path. So here are the procedures for the critical path method. Number 1, establish precedence relationships, determine the sequence of activities. Number 2, draw the activity on node network to present the project graphically. Number 3, identify the critical path, compute the shortest possible duration of the whole project. Number 4, compute the earliest start time, earliest finish time, the latest start time, the latest finish time, and the slack time. So let's try one more exercise problem. Compute the earliest time, the earliest start time, the earliest finish time, the latest start time, the latest finish time, and the slack time for each activity. So let's start from the forward pass. Let's start from the first activities. You have A and C. These are the first activities, the activities without any predecessors. So what's the start time? The early start time of A, 0, because this is the first activity. What's the earliest finish time of A? 0 plus 3, which is 3. How about C? What's the earliest start time of C? 0, because this is the first activity. What's the earliest finish time of C? 0 plus 5, which is 5. Now let's go to B. What's the earliest start time of B? Let's look at the predecessors, A and B. C. A is done at 3, C is done at 5, and we're waiting for both of them to be completed. So when are they completed? 5. Take 5, the maximum value. What's the earliest finish time of B? 5 plus 2 equals 7. Let's go to E. What's the, let's look at the predecessor. What's C is done at 5. That means E can be started at 5. What's the latest finish time of E? 5 plus 4, which is 9. Let's go to D. D is waiting for C, and C is done at 5. So we can start working on D at 5. And what's the latest finish time of D? 5 plus 7, which is 12. Okay. So we're done with the forward pass. And at this point, we can compute the duration of the entire project. What's the duration of the entire project? Let's look at the last activities. Right. We have 3 last activities, B, E, and D. Once these are completed, we can finish this project. And B is done by 7, E is done by 9, D is done by 12. And to complete the project, all of these need to be completed. So by when all of these are all these completed? 12, right? So if you have more than one last activity, then take the maximum value, 12. Maximum of the finish times. Now we can do the backward pass. So let's go backward. Let's start from the last activities. B. When is the latest finish time of B without delaying the whole project? Let's look at the duration of the project. The duration of the project is 12. And since B is the last activity, we can finish it by 12. And we are not delaying this project, right? So that's the latest finish time of B without delaying the project. Now, what is the latest start time of B? Since we need to finish B by 12 and the duration is 2, the latest start time is 12 minus 2, which is 10. Now let's go to another last activity, which is E. When is the latest finish time of E? Again, let's look at the duration of the project, 12. And since E is the last activity, we can delay it by 12 without delaying the whole project, right? 12, what's the latest finish time of E? 12 minus 4, which is 8. Now there's one more last activity, which is D. When is the latest finish time of D? The duration is 12, so D needs to be done by 12. When is the latest finish time, start time of D? 12 minus 7, which is 5. Now, let's go backward. Let's go to C. When is the latest finish time of C? Now, let's look at the followers. B is a follower. E is a follower, and D is a follower. And B needs to be started by 10. E needs to be started by 8. And D needs to be started by 5. So by when should you finish C? If you have more than one follower, you have to take the earliest time, right? 10, 8, 5. Which one is the earliest time? 5, right? Because you don't want to delay D. Okay, now what's the latest start time of C? If you need to finish C by 5, then you need to start C by 5 minus 5, which is 0. Now let's go to A. Who's the follower? B. B needs to be done by 10. That means A needs to be done. B needs to be started by 10. It means A needs to be done by 10. And what's the latest finish time of A? Start time of A? 10 minus 3, which is 7. Okay, now let's compute the slack. The slack for A equals 10, the lower value minus the upper value. 10 minus 3, which is 7. What's the slack for B? The lower value minus the upper value. 12 minus 7, which is 5. What's the slack for C? 5 minus 5, which is 0. What's the slack for E? 12 minus 9, which is 3. What's the slack for D? 12 minus 12, which is 0. Next, identify the critical activities. The critical activities are the ones with 0 slack, right? So what activities have 0 slack? C and D. C and D, these are the critical activities. Okay, this is everything we have for this part. I'll see you next time.